All right. Hopefully we are live according to YouTube. Hello, everybody, and welcome to a little ad hoc stream. We'll see how long we go on today. But I want to do a little bit more experimenting and improving of um, our little new XR Tools 2 logic. I'm specifically going to have a look at some of the stuff around the hands. So yeah, let's quickly run and sort of recap where we were with this. Hey Dave, how you going? Yep, of course. I exited. Come on, figure it out. There we go. All right, so I'm once again on Dev 7. So we're not dealing with the new UI for running. Still need to have a more of a play with how much is in there right now, and sort of create my own little wish list of what I want to see improved, especially for those of us who enjoy streaming. All right, let me just set this up a second time because of course it's bugged out on me. All right, now it should work. Okay. So there we go. We're back. My hands are moving. They're slightly shaking for some reason. So that's something that I need to look at and fix. I'm guessing you guys can see this all right. But the other thing, which is most important, is as you see that when I move around, my hands just don't catch up. You know, when I move my hands like this, I'm sort of okay that they're slightly more leggy. I do want to improve that as well. But that is going to take much better calculations around the forces that we apply. But I don't want to deal with that just yet. For now, all that I want to deal with is finding something for this. Now, last stream, we were looking at changing everything over to see if we can make the player body a rigid body and attach the hands that way through joints. I always forget to pronounce the T in that word. But that wasn't really working the way that I wanted to, and it's possibly that Godot just doesn't have the joint types implemented that we need for that, or might not expose some of the properties that we really need. There's still a lot of things that were designed in Godot's physics a long time ago that other physics engines have sort of moved forward from. And of course, Jolt, now being part of Godot, it has a lot more features, but they're not exposed yet. So that might be something to revisit in the near future. So for now, what I want to do is I want to actually have a look at our current dynamic player rig, which is the implementation extra tools that you can use to make a player buddy move. And we're going to see if we can do something around player movement and just make the hands move. And I'm actually going to use move and collide for that. It's not perfect, but it will do enough for what it is that we want to do and at least solve this immediate problem. It might react a little bit iffy when you're actually holding something, but we will deal with that as we get there. So that's our first task for today. Now, when we are looking at our dynamic player scripts, there are two forms of movement that are controlled here. And they are going through our physics process. So the first bit of movement that we're doing here, and in this one, interesting enough, I didn't actually split that out into two functions. And that's actually something that I really should be doing. I don't think I have done that. It's been a while since I wrote this, so I need to re-familiarize myself. But the first thing is And I've got a document actually for this. So hold on, I'll just show you guys this. Sorry, folks. I think it's in advanced room scale. So if you look at this document on the official Godot documentation called Room Scale and XR, there is a character body centric solution that talks about how this all works. So this is an older implementation. I've got a slightly newer approach in XRTools 2. But interestingly enough, this one actually splits it out into multiple functions. And I might actually do that in XRTools 2. That's probably a little bit of cleanup that I should do. But we basically do our movement in 2 steps. So the first step is when I'm physically moving through space, whether I turn my body or whether I take a step forward in my room, I want to make sure that the collision body, or the character body, moves along with the player, and we negate that movement on the XR origin to keep everything in place. So that's the first bit that happens here. And that's all that's happening over here up until about here. And then from here on out, we are actually doing movement based on our controller input. And we're handling that through, if we look at our player, oh, I don't have them here. Oh yeah, I've got my XR2 direct movement as a global thing. That's still something that I want to improve a little bit, but that one is possible to just put on one of the hands, but it can also be global where it reacts to either left or right joystick. But I do want to change that at some point in the near future and make it work more like XRTools 1, where we have a turn provider and we have a direct movement including strafe provider. But for now, it is solved like this, and yeah, I will be looking into that some more later and improving it later. Anyway, the point is that so there's 2 different movements that we are stacking, and that's also one of the problems that we're having with making everything physics based, because with physics, it's sort of the whole physics engine is about I am moving something by applying a force to it. And that's where the whole physics simulation works best. But I don't know how much force I need to apply to get my player to the exact position where someone made a step forward. With the controller input, that's fine. I can work with forces that way. That's fine. But when I take a physical step forward, and the same with like when I'm moving my hand and I want my hand to follow that, being able to exactly calculate how much force I need to apply to move the hand where it should be, that's just not what the physics engine is designed to do, especially not when you might have things in the way. You might, hit something and you want to push the hand through that. Yeah, there's some tricks there that become a problem. So we're going to have to deal with some of those things. The second thing, of course, is it being split into 2. I have a physical movement, and then I have a virtual movement through my joystick input. Those 2 movements could cancel each other out, or they could work in a weird way or interact in a weird way. And again, it makes it really hard to accurately determine where the player should end up, and therefore accurately calculate the force that you should apply to the player. And that's where the whole rigid body interface becomes challenging. What we're doing here is it's a character body, so we're using move and slide to move it. So this should always be a child of a character body. Again, that's one of the big differences between XRTools 1 and XRTools 2. XRTools 1 was designed that you extend scripts, that you use inheritance. While there is still some inheritance in XRTools 2, most of XRTools 2 is designed to be like an add-on. You add something to. Although that does mean that probably these 2 are going to disappear out of the player rig because they might not be used. Not quite sure about that yet. That bit, that is important here. So in this case, it needs to be channeled to a character body, and then the dynamic player rig sort of takes over the functioning of the or the control, I should say, of the character body. But it means that you could make a normal game and have your character body just act normally and have normal, joystick inputs if you want to, and then you could add the dynamic player rig as a child and add VR functionality to your game, and you can mix and match. That's one of the goals that we have here. And then obviously, it's between either you play in VR or you don't play in VR, and your controller mechanism just flip around. But because of the character body, we have more control. We can use move and slide to actually move the body where we want the body to move. It will then also, within limitations, interact with other objects around us. And hopefully, we get a simulation that we can actually use. Now, interestingly enough, yeah, I've got that move and slide here as well that I use here. So they're both using move and slide. Now, when it comes to the movement of the hands, I don't actually want to apply the move and slide, or I don't want to change the positioning of the hands when I take a step forward with my body, because when I take a physical step forward with my body, I'm also taking a physical movement forward with my hands. And at that point, I want to use the logic that we have already. It is when I'm making virtual movement that I want to copy that movement directly. That is still a little bit of a question mark, because there is a good reason for saying, no, let's also do it on this move, and therefore we have two places where we do that, or we kind of calculate the before and the after, and based on that, we handle it. But I think at this point, I just want to work on the first one. Not 100% sure yet. So that's actually the other question that I have here. How did I do that? Because if I've already handled the physics priority. Is there a physics priority on the hands? Because that was the one thing. So if we look at collision hands, and we go to the ready of collision hands, where are you? Here. And that one is -90. Now, if I remember correctly, that means that my movement is handled before my hands. Okay, in that case, we're going to start with just doing the whole movement, because the problem is if we get that order reversed, and we would apply the body movement, we potentially could apply our hand movement double in a single frame, because we would already move our hands forward based on hand tracking before we've actually adjusted our body, and then suddenly we adjust our body, we get that movement doubled. So we obviously want to make sure that that is handled in the correct order. Now that also means I'm going to steal a little bit here. I'm going to steal this, and I'm going to remove some of the logic there. So let's go and just plop that. So actually, I want to put that before the configuration warnings. There we go. Now, interestingly enough, I have not got physics process priority in there. And I want to go, of course, remove all those. That means that I actually want to go and add that one into the other script. So what does this do? This actually hides some of the built-in properties. So this is something that I've only just started doing in these scripts, but because we have a number of properties that we fix in extra tools, or a number of properties like in this case, where, so if I have my player here and I take my collision hand, we've gotten a number of properties here that control the physics of collision hands. Therefore, I am disabling a number of the inbuilt properties that we actually set with our own logic. And that just helps us prevent problems with people, thinking, hey, there's a whole bunch of rigid body properties here, I want to set them, and then actually we overrule those values in runtime because we have specific logic around that. So that's sort of just to protect the developer from mistakes. So that's why that is in there. Now, the other thing that I started doing here, which I haven't done in any of the other places, but I'm going to start doing that here as well, is create regions. So in this bit of source code, I can actually collapse all these regions, and I haven't written everything yet, but I've done most things. And it kind of organizes your source code a bit in sections, makes it easier to keep that selection on. I'm not sure. Kind of makes it easier to find where things are. So, and also to make sure that that everything sort of gets grouped together. So obviously this is not nicely sorted yet, but we will start working on that. So from our validate property onwards, all the way to the end, we're going to create a region. Create code region. Da, 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 da. And we are calling that, actually I want to call that the same as what it was called here, which is private Godot node function. So I believe that that is the thing that I called that. There we go. Cool. Sweet. All right. Those are actually signals. And if I believe correctly, I put those at the end. So let's go and create a region for that. Obviously, I can type it in as well. There's no magic here. It's just labels. But I just kind of want to have some of these things in a bit more organized. Probably want to do a whole bunch more. Did I separate out static functions, or did I just make that? Just made that public API, I think. And then here, and region, there we go. And then it's also just private. Maybe we call that a property. It's not really a property that we're doing here. I think I'm just going to add a region just for this. Eventually there will be more regions. This is just going to be private. And the question is, do we want them before the Godot ones? I kind of want them. I kind of want the Godot ones to always be last. Clean up a bit of white space here. Always do double spacing between these things. What did we do with that? I think there's like, so let's create a signal region. We don't have any signals here yet, but we're about to create some. That should actually kind of be at the top. That's not part of that constant. That's just a constant. I need to give that a proper name at some point. What else? Yeah, export variables region. There we go. That makes perfect sense. So we're going to put that over here. Oh, there are only 2 of them. Very good. And then we have private variable regions. I think, yeah, private variables. No, we keep those in there as well. Although if I ever use the lint function or the gdlint logic, then it might be handy to have a separate region for that. Okay. So with that all done, we're actually going to define a signal. Layer moved. From transform. Can I type this? I think so. Use transform. Oh, better come on. So there we go. I'm tempted to do a delta transform here because eventually that's what I will be using. But for now, I think that is good enough for what it is that we want to do. So if we have had movement of the player, and we're purely doing that from the physics function, then we're obviously going to inform anybody who wants to know about this. So yeah, that's something we still need to implement at some point in time. We don't care about that right now. Do we actually have a starting position that we keep? So we're going to do current velocity. And let's do a current transform. Current global transform. We're always doing global space. And I kind of like, if I grab these things, let's just be consistent about actually using that instead of always getting it back. So we can change that. We can change that. We can change that. We can change that. And this, again, there's part of me that wants to maybe put that into a separate function, but that's all right. So now we just have the one where we originally set it. What we really should have is some way to properly compare those two in both distance and rotation. And again, this is where it might be sensible to already calculate a delta and send a delta through instead. But is that smart? Probably actually is. Let's actually do that. Let's call this a delta transform instead. Okay, sorry, my nose is itchy as can be, so I'm not too happy about that, but it is what it is. Okay, let me quickly double check on something. Oh, the wrong one. Yep. Oh, my Steam timed out again. All right. Let's see. Where are you? So, that's the other thing that I really need to add in here, and that's just a little bit of foreshadowing for later. Is we're gonna add a teleport here as well. So if that is a teleport, then we want to react slightly differently to when we move normally. But we don't have a teleport yet, so we're not going to deal with that just yet. So at the end here, let's go and calculate that delta. Our delta transform is going to be our current global transform times our current transform, but we want the inverse of that. I always forget whether I should use inverse or fine. Returns inverted version of this transform. Like inverse, this method works almost any basis, including non-uniform ones, but it's slower. Okay, so I want to use the fast one because we know that we have a uniform transform. If we don't, then we are in trouble. Okay, so all right. So what we want to do here is, oh no, if delta transform, oops, origin. Let's check the distance first. We're not going to worry yet about rotation. We should add in rotation. To do also check rotation. So if you've moved more than a millimeter, we're going to emit our player move signal. And that is not a teleport, so false. Okay. All right. So now every time that we move, we get a signal, and we can connect to that signal if there's anything that we want to consume that with. So in this case, our player takes a step forward or moves forward. We now want to have the hands react and move an equal distance. All right. So the nice thing about this as well is we're doing this from our physics process. So we know that we're in the physics process part. And as long as we immediately react to that signal, then we're all good. So on our collision hands, we can now start consuming that. So the first thing that we're going to do is in our signal handling, and I'm actually going to make this all the way at the beginning because I kind of find this one important. So I like to always call my signal handlers on and then the signal that we're handling. So we're going to define that the same way, and I'm just going to go and add a pass in there. We're going to implement that in a little bit. And now on my ready function, where are you? There we go. We also want to connect to that. So somewhere here, we're already getting our parent body. Cool. That is already after we exit here because we don't want to run this logic in the editor, which is cool. So we're already doing that. Let's go and also connect. That's going to be our parent body. Hold on, that is the parent body itself. That is not the dynamic rig that we need. So we actually define that. Do we already have a helper function for that? Probably don't. We might need to create that. So that is going to be part of a public. Oh, we do already have that. And we actually get that from as a parent node. Okay, so we can go down. Our hand is always going to be a child of our player rig because that's actually our XR origin node. So I can actually make that something like this and say that is our dynamic rig is right. Hold on. We need you because that is a static function. So that's going to return a dynamic rig. That. And then if we have a dynamic rig, because we might not, so, you know, we might be adding our hand logic to a static rig or anything like that. Hey, Low Wheels, how you going? Yeah, we're not guaranteed that that is what we're going on. Let's see, that's timed. Why doesn't it see my signal yet? Maybe it hasn't parsed it yet. No, it has. I just haven't saved it. So we're going to connect to that. And we're going to connect on player moved. There we go. So that should mean that whenever our dynamic body, whenever we move, we emit that signal. We're now catching it over here. And in theory, that should be done before we do our own physics process. So we can move our hand forward by that amount. Just fill up my water because it's hot in here. Actually, it's been a pretty cool day this week, which is really good. Well, last couple of days, right after a couple of 35 Celsius days, that was really terrible. But we're down to, what are we down to? What's the weather today? We are down to Ooh, a cool 23 degrees Celsius. I like that way better than 35. Okay. So yeah, whenever we move, we now get that cold. That means that we can move our hand forward by the same amount, but not through proper physics. We're actually going to move it. We're going to force move it. But then after that, our normal physics will do the last little bit of movement. So yeah, that's going to be interesting that we're kind of teleporting it forward, but we're still retaining all our linear and angular movement of our hands. So it's like the simulation kind of works locally to where the player body is, which should be good enough for what we're trying to achieve here. And the way we're going to do that, and this is something that I found really interesting, I didn't originally know this was the case, but on rigid body, because rigid body is actually a physics body, we do actually have access to move and collide. All right. What is recover? Any depenetration from the recovery phase is also reported as a collision. Used this by character body 3 for detection. Okay. We don't care about that, so we're just going to call it. If it collides with something, we're not going to do anything. So if the hand can't fully move to where it should be based on our body movement, c'est la vie. This is one of the reasons why the teleport value is something that we are going to set through, and where we're actually going to say if is teleport. Actually going to pause here. Say to do. This needs to be implemented. Sorry, move and collide. So on a teleport, the thing with teleporting is that we might actually jump a fair distance. And we might jump past something that the hand would otherwise collide with. So in this case, we actually want to teleport the hand itself, which is going to mean that we're going to unset all the physics properties of the hand, and we are going to actually just place it there. We're going to ignore the physics. We're not going to let it collide with anything in between. The thing why I'm not implementing that now, but we're going to deal with that once we actually have a teleport function, is that I have no idea how that's going to react when we're holding something, when the thing that we're holding is using a joint. So we're going to have to see. In this case, we're just going to say we're going to move the same amount as the body. We're not going to do turning of the hand. If I turn the body and the hand just turns with it, the hand is going to move to its new location, but it's going to keep its orientation. We're not going to move it until we handle our physics again. So we might get a little bit of lag on the hand turning at that point in time, but I'm willing to accept that for now. All right. So in theory, it should solve our hand not moving right away, but it might introduce new problems. So let's go and test it. And before I can test it, I need to turn this back on to make sure we're in SteamVR again. By the way, this is the same way I solved it in XRTools 1. So I'm not doing anything that spectacularly new, but XRTool 1 uses remote transforms to move everything that we are holding. And that obviously doesn't have the potential problem with joint things. Okay, so now I'm having a problem that I am actually being pushed by my own hand somehow. All right, so we definitely messed something up. Maybe our movement isn't in global space. That's really weird, because one of the things that we did as part of our ready here Um, did I? Maybe. Yeah. This is weird because in my collision script, in my ready function, we are specifically excluding collisions between the hands and the body. Low wheels, how do you mean switch between layers of collision? Because that's one of the things that I also changed in Extra Tools 2. Is in Extra Tools 1, we put everything in different layers. And while that makes a lot of the code a lot easier, it also means that we have introduced a potential fault because people tend to forget to look at the layers, and if they configure the layers, things stop working. With Extra Tools 2, I am trying to make everything work without without adjusting the layers. So the only situations where you would put things on different layers is if your game logic requires it. There's some small exceptions to that. So for this, for instance, if I go to the physics layers, I did put projectiles obviously in a separate layer. First of all, so you can't pick up the projectiles, but also so they don't interact too crazily because that would cause a lot of overhead. But basically, we're not having any specific requirement in Extra Tools 2 on the user for putting things into separate layers. So if you never even touch the physics layers, you could probably build a completely working XR Tools game with Extra Tools 2. While in Extra Tools 1, you could do that too, as long as you were very careful that you always extend scripts. But since Godot in Godot 4 suddenly has allowed us, and I think it's a really cool feature, but it's allowed us to instantiate any named script through this. If you do that in Extra Tools 1, you don't get the scripts, or you don't get the scene, you only get the script. And that means you don't get all the default layers. So you can really screw things up if you add nodes through the plus instead of through the scene link. And in here, we do have a couple of scenes, but they're mostly around more the bigger building blocks. Almost everything else is all done with, and I think actually, no, this one does have some things. But a lot of the more complex things, I'm also just trying to just generate everything in code, just to limit, people doing the wrong thing by, because again, if I would add that dynamic rig in through the plus, then you'd break things. But okay, that's a bit of a separate issue. Okay, so we do have that they're not supposed to be colliding with each other. Is there something maybe in here that will tell us something? Yeah, I can do that. If you're not happy about that, I can do that. I just want to get rid of sort of these. I can't really get rid of that one. I need to go and find where the solver bias is being set. And this is something coming from one of the objects. For some reason I have in one of the objects that I'm importing, I have an empty mesh. So yeah, that probably isn't even a problem. That probably is just, it might even be my, call it, my little ragdoll here. It might just have a helper node somewhere in there, but it's classified as a mesh in the import. And then you get that and says, "Hey, you got a mesh without data." Well, just ignore it. It's just a node at that point. But I get why it's trying to warn me, because it might turn out to be a problem. Okay, so our collision hand should not be colliding with our body. So why on a move and slide does it suddenly fall over? Sorry for the noise in the background. My son's putting some furniture together. Oh, why am I here? That one. I'm the wrong one. That actually is also a signal, so that should actually move to the signals. Go and move to signals. That's really nitpicking, but hey. Okay. No, the hands were well. Maybe the hand is being moved to somewhere where that it indeed bounces into the other hand, but it shouldn't move the body. Move the body along the vector motion in order to frame independent. Motion should be computed using delta. In this case, we already have a delta, so that's fine. And it stops if it collides. Well, you know, we can see if we actually get a collision, just to see if we're colliding with something. Okay, go collision. Double O. I think so. We have one. Let's print it. That should tell us whether it's doing something weird. No, we're still doing that. Okay. Definitely doesn't like it. And we are indeed colliding with something. It would be nice if it actually tells me what the bloody thing, all that thing is. Okay, let's make sure that we type that. There we go. And I just do get collider and print that instead. Oh, print debug adds more info in there. Let's try it. Yeah, moving again. Oh yeah, and it actually tells us where. It's colliding against a static body. Ah, that makes no sense. How much are we moving? Actually, I don't like the print debug indeed. That gives me where it's being. All right. Oh, that's also gives. Actually, that's kind of nice to know. So it's the left hand is colliding. Oh, here it was all static body. So when did it suddenly decided to collide on the left hand? That's interesting. Also, the thing is, we're not supposed to be moving. So moving. Make a debug as well. Yeah, let's see how much we're moving. Make sure that I'm nowhere near the, even getting turned around now. That's really funny. All right. So we're moving just tiny little bits. Well, 3 to 5 centimeters. This doesn't make any sense. Oh, that's because we're being pushed. So this is kind of like a feedback loop. So when we start moving a tiny bit, Okay. Let's just move a tiny bit and see what happens then. And we're not actually moving our hands now, so we shouldn't be pushed around. Okay, that makes no sense right now. Because I've stopped it from actually doing a hand move. So we messed up our normal movement logic somehow. Okay. Because now it shouldn't be executing that anymore because we do have that return here. Yeah. Okay, that's weird. So oh, I think I know what's going on. All right, let's see. Getting our parent transform. So let's go and make sure that's type these. Kind of like that. Not really need it, but I kind of like it so. No, I'm taking my parent global transform. So this is also a. No, the hands are actually not moving. I just disabled the movement of the hand, so it's actually already something that I'm doing here. So I'm actually getting movement. Did I screw up something in my action set? Yeah, movement is on my thumbsticks. I put an enable on that. I'm just gonna go and do this. That doesn't exist, so that should no longer do anything. But now there should no longer be any movement. So why am I still moving? It's linked to which way I'm looking. Oh, hold on. Really? Really, really? Really, really? No, still. How is the movement at all possible? Why? This makes no sense. That makes no sense at all. Because with that should disable this. Oh, hold on. I actually have an enabled there. I could have just disabled it there. But I first want to find out what is actually moving my player. So on here. No, that's not the one I want. So let's just disable that move and slide.
Yo, that's not normal, is it?
That is not normal.
Yeah.
Do we still have the receipt for it?
Mm-hmm.
Because that means that they made a mistake with shipping or they damaged
Yeah, I'm about halfway through putting it together and I already want to burn it.
Why? Is that difficult?
It has repairability. In the sense that I think if you touch it wrong, it falls apart. Everything is held together with things slide into slots.
Yeah, that's normally the way that these things work.
Yeah, because they're all facing a singular direction.
Yeah, because finally you nail something at the back and that gives it strength.
Yeah. Except the thing you got to screw in goes into a hole that you can't guarantee lines up. So I'm just twisting it in, and if it's cross-threaded, at least it's somewhat secure.
Maybe you should wait until I have time to. The joys of flat pack furniture. Anyway. Okay, let's see if this at least disables the movement. We just need to find out where the movement is coming from. Oh, still getting that. So this is really strange. I wonder if I upset something. So now there should be no more movement because I've disabled all places where we move the player body. Indeed, we don't have any movement. Okay. Okay. I bet you that we that I edited something wrong when I copied all the current transforms in place. All right. Let me take out my secret weapon. All right. Oops. Oh, of course, because we know things that's going to be unhappy about something. There we go. So, parent global transfer origin became current transfer origin. That's fine. Global transfer to body location. That's fine. And then move and slide. Ah. But we have a rotation here. So this actually is no longer equal to this because we're using a updated version. So yeah, I was a little overzealous in changing that. So let's change that bit back. Okay, this one and this one. And that might apply further on as well. So here again, we do location offset. That checks player body location, which is what we. It's our new player body velocity, okay. Again, this needs a new value. So where are we now? Not where were we, because we're checking whether we got where we were expecting to go. All right, so we messed the code up. All right. So let's go back to where we started. So we were definitely looking down the wrong rabbit hole. Or going down the wrong rabbit hole. So, no, it's still not working. Okay. Let's see. So, velocity, I'm storing our current transform, that's new. Oh, I still have one here. Now move our, and that's the same one. We definitely don't want to use the old value there. That needs to be, you know, this is where Git is really handy. All right. And that also makes sense now that my head movement was giving us problems. So yeah, we're back to a working condition. Yay! All right. Let's see if our hand logic now works. Because, you know, we started off with applying our rotation, but then using the old transform. And of course, that gives us a difference between where we were to where we are, inducing a movement. Oops. guess that should move to signals as well. Now I'm just nitpicking. All right. So in theory, that should now work, I hope. So now we can see, moving backwards and forwards, our hands are moving, but churning, we get this offset movement. It's kind of weird because no, that's not weird. That is actually not weird because I am doing my movement based on where I currently am. Okay. That's a good one. And that was actually a problem that I was having with Extra Tools 1 as well. Because it actually means that I need to calculate where our hand should end up. And then figure out how, because my rotation gives me any offset for the player body, but not actually for the hand in the local player body's space. What did I do for that in here? Just having a look at the code of Extra Tools 1 on my other screen. Yes. So what we're going to do, we're going to calculate a target, which is going to be our delta transform times. Now let's do that to times global. So now we actually apply that movement correctly to this. Do we? Is that true? I don't actually think that's true. And that's, I think, what's wrong in Extra Tools 1 as well. And this is a bit of a problem. Because it's the delta transform on the original space. I think we are going to have to censor the before and after transform. I think that's the only way we can solve this. Yeah. So this is going to become from transform to transform. Okay. Let's go and change that here. It's obviously going to complain, but it's fine. Fix that up in a minute. And then obviously here on our process. Oops, I scrolled too far. So this is going to be current transform, new transform. Actually, huh. Mhm. Yeah. Okay. All right. So now that we have a from and to, we want our okay. So we want our hand position, which because remember, our hand is also disjoint from our body. So we can't go down our parent tree because this is being set as top level, so it's moving independently. So we want to know our hand position in relation to where our body was. And that's a good question. Is that already being changed by this? No, it's not, because again, it's top level, so we haven't actually adjusted our hand position yet. It's still in the old location, in the before movement location. So now we know the hand's position in local space of in local space of our player body. And now we need to get our new actually I call it target transform. That is going to then become to transform times current local transform. I think that's the correct way around. And now we can say that the amount that we move, no, it's actually not that, because that's in global space. Actually, let's call him delta movement. 3 is target origin global transformed origin. Sorry, my eyes are stingy. Which means I can just plug that in here, and I can plug that in there without the origin. And well, we might remove that later on, but that might be handy to do. All right. Why is it complaining about that? Actually, hand attachment, get environments, there it is. What are you complaining about? It's there. You're drunk, Godot. You're drunk. All right, let's see if that now does something a lot better. Okay, that really screwed it up. So we got something the wrong way around. All right. Yeah, that's definitely not right. So there's a typo in here somewhere, or something that we're doing in the wrong order. Um, okay. Is this the right way around, or is it? I think something I've got flipped here. It's always right to left, if I remember correctly. Or is this the other way around? If we can do an inverse. I need to do both of those. I always forget which order the matrix calculations go. Okay, that was my problem. I had that the wrong way around. But as we can see, rotating, moving forward and backwards is now, and we still have a bit of the vibration here. But at least we have this all working. So we can see that we're still having that logic working. So even though we move into it, our hands stay behind. Should work here as well. If we go and move into it, boink, yep. Oh, broke that, I guess. That's still working. Okay, cool. Close it. There we go. Okay, that bit all works. Now, the really big question that I have is, how well does that work? Okay, so here we can see, because we're now holding an object, it's still kind of reacting okay-ish. But because now we're actually moving our hands forward, we're actually introducing, because we're not actually moving the object that we're holding forward. So what's basically happening is, if I've got my box here, there, let's say that that's my box, and I'm grabbing that with my hand. Now, because I move my body, my hand goes here. Let's actually go the other way. It goes here. And now Godot physics works and says, oh, I need to move this to be back there. So I now actually have a velocity on this. The hand doesn't, because I used move and collide to move my hand, which doesn't introduce a velocity. But this does. And at that point in time, we get that whole wiggly sensation. Now, I want to see how badly that is when I'm holding the gun. If that also works with the, come on. Now that really doesn't like it. That's hilarious. So yeah, because I'm now moving my hand outside of the whole physics simulation, the joint is actually pulling the gun back to place, and it is not happy. It's funny, but it's, oh, actually my hand animations don't work either. I wonder why that is. I must have disabled something. But yeah, that's the problem in the end is we get rid of that. We don't care about that at the moment. Therefore, do that. So, because we're moving our hand outside of our physics simulation, but then the physics simulation to catch up, it is not happy. Now, I do believe that we can probably fix a couple of things there, especially around the gun. But what we really should be doing at this point in time is applying that same movement to any object held. Now, that's going to pose a different problem, because if I am holding an object with both hands will be moved like this. Then both hands would then try to move the held object into place. Yeah, that could potentially go very bad. So I would need to somehow find a way to then mark it as I've already moved this. Don't have to move it again, because it's held by two hands. That's really why I don't like the move and slide or the move and collide solution here. But I don't think there really is a lot different than we can do. In order to make this work properly. Because again, we are introducing a movement that the physics engine is not aware of. It's really annoying. All right, let me first figure out why. I think I probably disabled some things last time I was testing. Yes, I did. Just gotta put them back on. Yeah, I want to. Okay, that should mean that my fingers move again. All right, so this fix, however, I also need to apply to XRTools 1, because that now finally explains why turning in XRTools 1 didn't give the right result. Let's just solve that one. But how to deal with this properly? Because that's a thing, you know. What else can I do here? Because what really is needed here is to figure out how much force to apply to the hand to make this movement. But at the same time, that also kind of means that the hand should stop immediately when it's done. Well, I can change this delta movement to, you know, how much velocity does the hand need to get there in order to do that, which unfortunately would also overrule our current velocity on our hand, which would have a negative influence on the rest of the simulation. But I still have the same problem, right? Is when I look at the thing that I'm holding, yeah, I'm now suddenly putting a velocity on my hand, but this object doesn't have that velocity. So suddenly there is a force translation between that, where the physics engine doesn't realize where this movement is coming from. So it doesn't know how to react to this. But we could try. We could see if we can make something out of that. So one of the things that we could do as an alternative is say, let's make that part of our linear velocity. Now, because this is additional, no, I'm just going to have to set that. I can actually set that to delta movement, because that is, no, I need to do that divided by delta. I don't have delta here. This is in the physics, so I can cheat. Should be able to get that for my physics engine. No, let's go. Yeah, but remember, I don't know what the object weight is. I've got no idea what is attached to my hand because I'm using joints. And you know, whatever is attached to my hand might have something else attached to it, might have something else attached to it. So trying to figure out how much force to actually apply is near impossible because I don't know what the total weight of the hand plus all the objects that are currently interacting with the hand, especially because when I have two hands holding an object, you know, it gets even less, and especially when rotation comes into play, which is already why that hand shaking is a problem, because we're trying to sort of overpower the system. We're just giving a really big force in order for it to lift something. But then when it's not holding something, the hand would fly off. So we have a very high damping on the hand to make sure that the hand doesn't fly off. So I need this one. That's the one that I need. Okay. Be able to so this what it states. Get rid. There we go. I'm kind of okay with that because we're already introducing a separate type of movement in there. Let's see how well that works. Okay, at least our hands are working, but that velocity thing doesn't do what it's supposed to. Hmm. Yeah, it doesn't like that. Hold on, let me just print step because I've got a feeling that is actually not what I think it is. That might just be the actual value for this. Okay. All right, it is what it should be, but there is a situation where it is 0. And that's really interesting. In what situation did we have that it I don't know about that. That's not really doing anything. And I'm thinking that is because of our drag. So the problem is, in order for the collision hand system to work, we set our drag to something really high. So even though we assign this velocity here, the first thing that gets done is we apply this instant, this very high drag value, brings the linear velocity to 0, and then we do our normal hand logic. So yeah, the other interesting thing is, so this is actually not working. But let's see what's actually in our state, because that might give us something nice to work with. Never really looked at that because let's just see if that changes anything. Ah, come on. Field physics direct body state. Yeah, nice. I want to see what's in there, dude. Really? Interesting that it says it's a jolt physics direct body state, and we don't actually have that registered as a type. Okay. So we have a current, angular, and linear velocity. So we do have our inverse of our mass, but that's just the body, I think. Because that is something we could try as well, but here gets the real problem when that's the inverse of the mass. So I'm going to inverse it again to get the actual mass to print. And I'm guessing that regardless of whether we're holding something, that's going to give us our 0.4 kilograms, which is part of the problem because, yeah, now I'm going to apply a force. I'm going to do it as a central force. So that in theory should move our body enough by itself. Although I probably should subtract a current. Ah, that's giving me an issue. Won't. Oh, because that was named inverse mass. I bet you. Inverse mass, yep. Why does it always copy a new line with that? So annoying. What was I going to say? Yeah, so that just applies another force. Well, we've got our really, really high damping to help us out, I guess. No, that's again not doing enough. Oh, hold on. Did I do the right one? Was it impulse or force? What did I do? Force. Is that the directional force? No. Force is time dependent and meant to be applied. Okay, I think this is adjusting it by No. See if that makes a difference. I actually think we have an inverse mouse here. It's not giving that. Yeah, if it's just returning one. So I have a feeling that's not even implemented in there. Well, we can do it without that, and instead say it becomes divided by. Did I call it hand mass? I did. Just for the idea whether the principle would even work. No. I think that one's dead end. I do believe that is a dead end. All right. So this really seems to be the only way to go about it. And I think the problem there is that we if for that to work, we would have to do it in the process function of the hand itself. So we would have to store this as a, hey, we need to move the hand this much as well. And then in our physics process, we then say, oh, calculate how much we want to move on based on hand movement, but we also want to add in the this movement as well. But we're still going to have the problem that in order to do that correctly, we would need to know far more about the weight of whatever it is that we're holding. Full bar. Also, with the impulse, I'm actually pretty sure, or with the apply force, that is a force in meters per second or newtons per second or whatever. So I probably still need to upscale that by our physics step. So by our delta. Which is actually a thing that is still something that I haven't solved correctly in here as well. Because I noticed that on different frame rates, this behaves slightly different. Let's have a look for the other things. So yeah, this is probably all way too high. That a little bit lower. Let's see if that shakiness gets dealt with. Okay, that's a lot less shaky, but makes the movement also a lot less quick. There's more of a delay now, which was annoying. But yeah, we still have our problem that, yeah, gun gets completely... It is funny, though. I have to admit that. But yeah, it's not even liking, even though I'm using my move and slide to move my hand, the fact that it now needs to pull the gun along. Yeah, it's not happy with that. So move and slide is not the solution, but we're getting nearer to the solution that we need. All right, let's see if we can do a variation of. Let's see if we can at least get that to work. Oh, not that. Same there. Um, let's start by okay. Let's call it extra needed movements. There we go. So it's in here. Do that as so let's add that in. It should never be more than one, but you never know. And with that, let's go to our physics updates. Physics process. We're gonna actually end up using you. So here we have all, like, if we just do it, then just do it. Okay. Right. No. Let's move that over here. That's handled. Because you can add that in here as assuming that we've actually applied that movement. And we're now just adding an extra force for what's left. So what we're going to do here is bar force 3 needed movement divided by delta. That gets certain movements by that, and this needs to also be actually, let's start with divided by mass. That's something that we need to do a nice calculation for, and for that we need to see if there's multiple objects holding something. I think we can deal with that. Then now we get linear force divided by delta. So that should be our force needed in total. Y central force. Okay, so if we're not holding something that in theory should be exactly what we need, but if we are holding something that's going to be way too little, no, still, why is that nowhere near the force that we need? This is an acceleration force, which is why I'm dividing by delta. Should maybe be divided by delta squared. I'm not sure. I'm wondering if it doesn't work with applying central force multiple times. It should. So what am I doing wrong? What am I thinking wrong here? Actually, isn't this times mass? Even though that makes no sense for here. Because I did divide it by inverse mass before to get that. Or is it? You're trying to accelerate it to that distance. Because again, our dampening is very high, so our current speed is being negated. So we don't have to worry about that. So I should be able to say, this is how much force I need to give this in order for it to move to where it's needed. Yeah, the force is going to be more depending on how much mass I have. Let's rename this a bit. Needed acceleration. Extra movement divided by delta. Again, it's an acceleration force, but linear force is going to be extra. The acceleration times mass. Is that correct? Or am I missing something here? And then apply a central force. Okay, just in case I did that wrong just before. I don't think it matters. No, it still doesn't do anything. All right, so first check, do I have? Is it even running? Let's make sure of that. This is almost trial and error at this point in time, just to see if we can make it work. Okay. Yeah. So yeah, we got the amount of movements. This is the thing is when we look at the force coefficient that we need here, maybe that's because the drag is already taken into that. Hmm. The only other thing that I can think of is actually taking out the drag and doing the whole calculation with the proper amount of well, we can test that real quickly to see if that actually does. Bokeh, that's the problem is because we can't move something exact, we are applying a force in order to make the hand move to where we want it to be, in so that it also then applies it correctly to whatever is being held by the hand. We don't know the exact numbers that we need to apply in order to get the hand there because we don't know enough about our simulation. We don't know enough about the weight of what being held. We also would have to go and figure out everything that's potentially connected to what to what we're holding. We might be holding something like the door, which is on a hinge. So again, there's a lot of missing information there because we're doing something that the physics engine was never designed to do. Physics engine was never designed to do exact movements to somewhere because your hand has moved without, your physical hand is moving basically. So makes it hard to try and figure out, okay, how can we move that? So coming out the original ones, I'm going to turn this back to a normal damp value, which will completely screw up. Or actually, I only want to do that for the linear. I do not want to do that for the angular damp. So we're gonna keep doing the angular thing the way that we currently do. So I don't really think there's any other way to do the angular rotation. But we could maybe change this here. But now we would really need to know the actual for now, we're just going to copy that. But we should actually start calculating what additional mass we need to work with. In this case, that goes there. So that should now work. But now this one is going to be wrong. So here's the same sort of thing. Is going to take that out. What we need exactly. I'm going to shorthand this for now. For the linear movements. Because again, we're going to assume that this has actually moved it there. And the reason why is because this, if we do this application, especially if we have the correct calculated mass, we want to limit that to a maximum. But let's start with this. So that's times delta. That is 28 times mass That would then be F. So that should, in theory, work just for the hands as they are. No, that's indeed. Oh. Yeah, it's funny that way. And that's because we now have the actual existing acceleration in there that we now need to negate. So that is something that we need to add in here. Unless we just go and be really bad. I don't really want to do this. But just to see if the forces that we apply are actually sensible. Although see, the force is nowhere near what it should be. And that is something I just don't get. Although I am taking the simplified approach here, I think there needs to be a quadratic function in here somewhere. Because we're trying to figure out what is the acceleration needed from where we are to get exactly where we need to be. No, okay, it's not so a Boca. So that's part of the problem is, you know, again, I'm just testing with just a hand right now to see if I can get this to work the way that it should. So yeah, if I can figure out how to do it this way, eventually I would have to then start traversing and trying to find the total mass of my hand plus everything that is attached to the hand. And then something like this would be able to get pretty close to doing the actual acceleration needed. But the thing is, when I do body movements, I want to not limit that. But when I do hand movement, I do. The problem, of course, is any movement I do, you know, when you move your hand from here to here, or let's do the other way around with the camera so you guys can see, I move my hand from here to there. It's actually a force that is applied to move it there and then a force to stop it. Potentially, because I don't know what's going to happen next frame. I don't know if that movement is going to go through. So when I move it from here to here, then the next frame, I now have a velocity. I want to move even further. So now I need to, at that point, say like, hey, now I've got a velocity. I need to negate that velocity, and I need to slow it down. The thing then, of course, is that if that movement was because I moved my hand, because I'm picking something up, I want to limit that because that is going to give me my weight simulation. But when I move my body because I'm moving a step forward, I don't, because now all of a sudden, if I take a step forward or I use my controller to move forward, if I now have my weight simulation and my hand says, but I can't move my hand forward that much, I can't exert that much force. While in reality now I'm using my whole body to exert that force. Then suddenly I have this disjoint. So really what I need to know is that, hey, my body movement gives me this potential amount of strength to move forward. I already have a velocity that moves me forward. So those two can sort of negate each other, so to speak. Although again, if I stop, then all of a sudden my hand would be pulled forward because I've got an existing velocity. I don't have enough strength now to pull it back. So somehow I would need to take that into account. Unless I only want my weight simulation to be horizontal. And again, that is one of the reasons why we're using very damped values. And again, I could actually stick to that because I'm pretty sure now that my calculation here is wrong. And it's probably because, you know, acceleration is not linear, it's exponential. So if I look at the, you know, this linear movement as the, you know, assuming that I'm standing still, as the acceleration that I need in order to get from where I am to where the hands should be, then I can't simply divide by delta to figure that out. I need to, I might need to do that with delta squared. Okay, let's see, calculate acceleration needed to purposes. Here we go. Given time and distance. Sorry, I'm just having a look in Google at the moment. Velocity, final velocity, and distance. Use the following equation. Okay, so just to recap some nice math. That the acceleration that we need, so distance is current velocity times time plus 0.5 times acceleration times time squared. I'm going to write that out like that. I can't do the little 2 thingy, and I don't know what the keyboard command for that is. All right, so assuming for a moment that we are not using our current velocity because we're negating that. So we're going to take that out of the equation for now. assuming current velocity, because we're our dampening of 100 is going to completely take that out. And that, okay, which means let's actually write that the other way around. Oh, you can write that the other way around in a minute. So it's 0.5 times acceleration is distance divided by time squared. Actually, I could have added that in there. So half. Okay. So let's see if we do that, whether we... Did I do that right? I think so. Yeah, I think so. So... I really need to have something else here. Whatever. I'll think of a better ring to call that eventually. So, factor 0.5 times delta times delta. Delta is the time over which we want to traverse our distance. We have our needed movement here, so this now becomes divided by factor. And then we have our mass. So let's do this as well. Factor over our mass. All right, let's see if that makes more sense or not. It's closer. It's pretty close to what we want it to be. Looks like it's slightly behind still, but that might be because of the velocity. I don't like that. All right, hold on. We're going to make this even nicer, I think. Okay, what if we actually add our... What if we add our current velocity in there? What if we keep that in there? So... that would be distance minus current velocity times t. Perfect. And now the acceleration needed becomes... Oops. Was a little bit too helpful there. Okay. Well, I'm first trying to get this to work without, so I actually don't want to have the drag in there. So I'm actually going to go and take that out. You have like a default drag. Max linear velocity. Default linear damp, 0.1. Yeah, I find that's a fine enough damp. No, this is a specific implementation that I'm trying to get to work. So a completely physics-based implementation. Just want to disable this a little bit because we're going to concentrate on having that actually completely work here. So in this case, we have our current velocity times delta. So in this case, we would have this minus linear velocity delta. Add that in. And then assuming that we would have the correct mass, in theory, that should be the correct value. No, to really, if you want to start with using VR in Godot, the recommendation that I have is that you use the XR Tools library. You can find it in Git up here, but you can also download that from the GitHub repository. And that gives you a whole bunch of existing logic that you can base it on. This is kind of a new version of that I'm working on, but that's still very far from ready. The other one that I really recommend is on my own channel. If you go to videos, you will find a, where are you? Here we go. Getting started with OpenXR in Godot. That's a really good video to follow. Unfortunately, a lot of my tutorials are Godot 3 tutorials. A lot of them apply. So for instance, this one, the XR Tools series is kind of good to follow. And most of it still applies in Godot 4, but you'll need to sort of make some smart adjustments. The other page I can really recommend is my friend Malcolm Nixon. He has a lot of videos here, including a number of tutorials on XR Tools, although you do have to go back a little bit. So here is our movement and a grab point, staging, world grab, basic movement. So he's got a whole bunch of things here that show all functionality of that. Yeah, and there's if you search for it on YouTube, there's a couple of others that have some really good things. Yeah, Muddy Wolf has got some really nice ones. So that's Muddy Wolf, I think. Oops, not Muddy Wolf. So he's really cool. There's a whole series here that is in Godot 4. So you find that VR4. That is a pretty decent series that gives you all the basics. So, oh yeah, there's lots of things in there that you can actually look at and see how does it work. And he's actually working on a new set of videos, so that's pretty cool. And oh, what's his name? Virtual Rook. This one's a nice one as well. He's only just started with some tutorial videos. So he's got a getting started video here, which is kind of nice. But he streams quite regularly as well. And, you know, he's still a relatively new, still learning how to do VR in Godot, but he's doing some cool things. And he's got a really nice bow and arrow game going on. So anyway, back to this. So here I'm going to ignore the extra movement. I'm just going to do the movement as we should. Now, obviously now we have our applied mass. Just with the hand mass, we actually have to figure out a little bit more about the mass that we need to use. I'm going to keep the angular the way that we do. But in theory, with this, we should be getting pretty much a proper force. And this might still need to be a divider of the mass. I'm not quite sure about that. So yeah, that is staying pretty close to it. It's got, definitely doesn't do the acceleration, but there's still a little bit of lag here. And I don't know whether that is a drag or whether that is something else. So, well, one thing that we can do is we can take the drag out completely. The magic symbol, the stronger this fella is. Oh, there is one thing I'm probably not gonna find in tutorial. How would you go about spellcasting sounds similar to War of Wizards? It's really cool because the larger and more accurate you draw, the magic number. Okay, yeah. yeah, doing a gesture with your hand, that is tricky because you need to find a way to sort of figure whether you've moved the hand in the, you know, in the right shape or not, and differentiate between different shapes. So I think you can find some good tutorials on how that is done if someone uses the mouse to draw a shape. Um, and then you'd need to translate that into, you know, well, yeah, you need to translate it into 3D, but what you could do is use the local hand movement, and then just do the hand movement in X and Y, and ignore the depth, and then you could basically, you know, use the same logic as what, you know, mouse drawing sort of logic is. But it's, I think I have some ideas of how I would do it or how I would be able to fake it, but um, I'm not very. I haven't ever tried to implement something. That would be cool. Anyway, I wanted to. No, so I'm gonna do replace here. I'm gonna do the same thing here. I'm just gonna replace, and I'm gonna see if that actually, whether it's the linear damping that was giving us the reason why. No, it's actually making it worse. So it's almost like it's like a frame behind or something, which is possible because oh, it is because I removed this. Okay. Actually, let's keep. No, I want to keep that out. All right. So let's see. That was indeed causing it to be a frame behind because I was taking that out. Okay. Well, it's closer. That's still pretty decent. Okay, how does that work? Now, of course, if I pick up something now. Okay, that is working surprisingly better as I thought, except that the rotational. Okay, I am slightly surprised that that is kind of working. Yeah, we're getting way too much. Yeah, because okay, that is weird. That is weird. I don't. That makes no sense that that works. Um, that absolutely makes no sense. Because the mass of whatever I'm picking up should be. Hmm. Well, but okay, if this works the way that it's supposed to work, then the drag shouldn't matter anymore because I'm already taking the linear velocity in account. The fact that we put the drag really high was to, you know, that was what's his name? I've got it written down here somewhere. Depth as solution, and that's a brute force solution where we're just applying a force that's way higher than needed, and then a high a high drag to then slow the hand down again. And that means, because this is the thing, right, is the heavier the thing that you pick up, the more force you need to exert in order to keep the hand where it is. But somehow here I am completely negating it. And obviously my my angular movement gets screwed up because actually I don't know why my angular movement gets screwed up. I actually going to turn this back because that was fine. That little bit of damp isn't going to make too much difference. But here it stops making sense that, because yeah, again, slight offset doesn't make sense. But also, that should be I think what is happening here is it? Um, hmm. Oh yeah, so what to do that? Yeah, this really makes no sense. The thing that I think that's happening here is because the lower my hand gets, the more velocity downwards I'm getting based on how heavy the thing is that I'm holding. Oh, ice cream. And it's actually that is creating. I think it is that is actually creating the automatic correction, because the weight of the hand is pulling down, is creating a certain velocity downwards. I'm saying negate that. Don't want that. And that's automatically as soon as the hand falls or the weight falls slightly off, that's going to counterbalance it very quickly. And as a result, I'm always calculating the right amount of force in order to get the hand back up, even though I'm using the hand's mass. That's actually kind of cool. I wonder if this actually can be applied here as well. You know, yeah, they're angular. This is actually working way better than I was expecting. All right. I just want to write it out again. So I've already decided that I don't need to do this. I have no idea if I can do that, but we're gonna see what it does. It might actually get close enough to what we want. It's a little cheating, but just want to write it out. So here, this is my old solution. So yeah, I've already got my angular movement here, so that becomes angular movement minus angular velocity times delta That is the factor. This velocity is always a bit of a problem with this, but and this is, I'm not sure if this is actually. Oh, I need to, of course, do this here. Because we're talking about torque, and I'm not quite sure if we can do this because it's all, you know, momentum and everything like that. But who knows? Actually, let's go and pull that torque. That might totally not work, but you never know. What did I screw up? Screwed something up. I do not think that has anything to do with this. Let's double check. Let's undo my changes. And if it still does the same thing, then I just broke something. Oh, yeah, I broke something. That's what you get for renaming things and trying to do it quickly. What did I do? So factor is still that. That's cool. Applied mass is still what it is. Okay. Oh. Ha 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 ha. There we go. Yeah, orbital heads. That's just a. There's a game idea in that for sure. Okay, that's back to normal. All right, let's see if our hand rotation will now work. Do this. So I'm going to disable the old, enable the new. Okay, that's definitely not good. That's stabilizing it somewhat. But yeah. Why is it? Okay, well, that's what we get for trying to sort of shortcut it. Because the problem is, how do we go from velocity to torque required to create that velocity? And one of the things that we could really see was that torque was really low compared to our force. And doing the calculation we're doing here is really putting that onto steroids. And that is because we have a velocity in changes in degrees or radians. So let's go and find out if someone might have an answer for that. Radial relation to torque. The moment of inertia times the angular acceleration. The torque exerted on an object is equal to the product of the object's moment of inertia So how do we calculate our moment of inertia? Integrating over the mass of all parts of the object, distance and center of rotation. To look at moments of inertia for common shapes. Work again, axis is the product. Okay, that's a disk. How do I know the moment of inertia? Okay, moment of inertia. Box. Okay, in meters. Okay. All right. This is annoying because it's shape based. Hmm. All right, this is going to be fun. Mm. Torque is moment of inertia times angular. So, let's see. First things first. I'm actually going to go and change that to that. We don't need you anymore. So same thing here. Oh, that's right. No. Set copy. Paste. So I don't need this anymore. So now I'm actually going to go. Put that there. I don't need that anymore. I'm pretty happy about this new approach. It actually also means that I no longer care about this. Um, this we will need to do something with, but that is for later. We no longer care about you. And we no longer care about you. Okay. So eventually we're gonna add a max here. We'll deal with that in a bit. All right. So, torque. I've actually never learned about torque. Torque. Equals moment of inertia. Blank. Moment of inertia times angular. So now we need to calculate our moment of inertia. A moment of inertia for a cube. I'm going to use a cube, even though we've got a more complex shape. But we're going to assume, when we look at a hand, we're going to assume a shape around this hand. We can sort of figure out what the bounding box of this thing is, which we probably can figure out on the hand itself. For that, pretty sure. Oh, we're gonna have to figure it out in a minute. We might just draw a box around it and just use that to see if we're even on the right path here. Where is my function that we're doing? So when we look at that, we need to do that on every different side. Okay, so we basically have the variations of this. So that's going to be mass times y times y plus z times z, and we're going to divide that by 12. Again, I can't do little square things. I wonder if I can actually, I see that. Unicode. Can I do that? Yay! Yay! Okay, I'm gonna do that here too. That looks way better. I'm gonna just take that out. We don't need to keep that in there. So that's our distance. So we actually can take that out completely. Just acceleration is distance. We're gonna calculate that here perfectly. Blah blah blah. Do acceleration, and then force is simply acceleration times mass. Cool. Here, torque, we have that. So, y, z. That's going to be x, and that is going to be x plus y. So those calculations we need to do. But for that, we need to know our size of our hat. The easiest way, and again, I'm just approximating this. Let's add a remark for that. Approximating moment of inertia. Bounding box. But we don't have a bounding box for our hat. So I am, going to just go and left human right hand. There we go. Children. Excuse me. So either we're going to draw that box around it because that's the bounding box that we want. This one. But I'm pretty sure that we can obtain the bounding box. So mesh instance 3D. Boom. Do we have a way to get that, or do we need to get it from the mesh itself? Mesh. Get AAB, that's a virtual one. Get AABB. Not affected by custom AABB. Okay, so we're just going to go and call get AABB on the mesh for that and use that. So bar and size vector 3 is that one, but we need to do that from the right thing. So where am I adding that in again? Sorry, I'm being nitpicky again. Where are we? Okay, we're loading our hand scene. Oh, look at that. I have already wrapped that. No, that's the whole scene. I need to know. I'm getting the skeleton. Doesn't look like I ever capture. Get mesh insist now. Yep. Okay. So can't get it, I'm just going to use a little default. I'm going to assume that we're going to be able to get it. All right. So, we'll make our life easiest is if we go and already duplicate that. So, we're going to say hand size is hand size on hand size. Oh. Power of 2. That now means that we now can very easily calculate our moment of inertia. Vector 3. Size. Just need size there. All right. So vector 3. So this is going to be hand size dot y plus hand size z and dot x plus hand size z and size x plus and size y. Just write that out a little bit. This makes it easier to read. Okay. That's going to be times our hand mass divided by 12. That should be our moment of inertia. And that means we should just be able to do that. And just to make the formula happy, I'm going to put that at the start. Now, no idea if that is going to be a sensible torque value. Neat. No, doesn't look like it. Still really. Okay. The thing that I wonder about. To get rid of that, we don't need that anymore. The thing that I wonder about is whether we're getting this in the right order. And again, I was using that here as already, so I'm assuming so. Oh, hold on. Wait. Yes. We are dampening everything. And we are still keeping our momentum like that. No, still no luck. Okay, so we're getting an immense amount of rotation. Why? Oh, yeah, we at least have a size. That's pretty cool. So that's working. Didn't even check that. I wonder what a divided by 12 comes from. Did I miss something? Oh, hold on. No. Yeah, in radians per second. All right, just to test this part out. Let's go and nullify our current angular velocity so that we just get the velocity needed to move. So that's already shaky. So we are definitely getting the wrong value for what we're doing. And there's a possibility that, you know, because we're doing our moment of inertia as a gamble, well, I'm assuming that's actually a good question. Let's look at our directs. Do we actually have? We have an inverse inertia. Inverse of the inertia of the body. That is interesting. But why do we get the inverse? Huh. But we have that, so we might as well use it. Why do we have the inverse of that? Oh, but I do suddenly realize what my mistake is. Because I need to rotate the inertia into global space. Ha, that's why. It'll be interesting to compare the inertia that we calculated with the inertia that we get from the body state. That could be interesting. However, the thing that I have forgotten to do here is, so here's my calculators. Inertia, and then rotate. Because again, our angular movement is in that space. Let's test that out first. See if that makes any sense. See if that was indeed the right thing to do. No, not really. That's hilarious. Very good. Nope, that is not what we want. I'm not even sure if that's possible, what I just did there. Again, as far as applied torque, applies rotational force without a special position. Force is time dependent, meant to be applied every physics update. Note inertia is required for this to work. To have inertia, an active collision shape must be child of the node, or you can manually set inertia. Yeah, that's fine. So you get the difference. Rotation. And that is in global space. Maybe that's actually not needed. Okay, let's go. Let's see. How many times have I done this before? Quite a lot, I think. Is physics server B body gets direct states get grid. There we go. It states our moment of inertia is state that gets inverse inertia, assuming that that is then that's that's just an no, it doesn't allow us to do that. So this should actually be for 3 divided by 7. Does it allow that? Yes, it allows that. Now I want to do print. I just want to see what that does. Okay, cool. Let's see what we got printed. So that's what thingy gives us. That's what we came up with. Oh, it's definitely pretty different than what we are doing. Although it's in the same sort of general order, I guess. Also interesting is that it changes. Okay. Let's see if we use what Godot gives us, whether that actually gives us something that is useful. Oh, we still get vibration. I don't know. It just feels like we're on the wrong track again. How do you mean low wheels? I don't know if you guys can really see that the hand is actually doing that, but then very very light. So we keep over correcting, and that means that we're calculating the wrong amount of torque for what we need to do. But I do think that this is the right way to go because now we're using the moment of the inverse inertia that our state gives us. And I'm actually thinking that while this is cool to keep, I actually want to go, I'm going to park it. I'm not going to throw it away. So I am just going to go and put that into a document. Um, there we go. No, this is just the track control, right? So I'm just trying to figure out, what position that is in, and then comparing that. Okay, so I'm just going to print that to make sure that we get values. I really should probably get this way earlier. I'll leave it there for now. This is still going. All right, so what I want to do now is go and so this should slow down the rotation. So now we can see we do have a rotation that seems kind of in the direction what we want. So that obviously doesn't work because now we're not putting enough strength in. Still wondering if I don't know why this is so unstable. I don't know. So again, I'm wondering if that is axis aligned somehow. I'm not sure. If I make that. can still see that, yeah, we're definitely over calculating it somehow. Okay, let's halve it. Still way too much. That looks spot on almost. Okay. But then this doesn't have enough strength to. So interesting enough, what we're having with our movement, if we grab something and the movement is still. I really like that. Yeah, because it can't correct the rotational amounts. And this is also where it really gets more difficult, because once I pick something up, in order to get the right torque, I actually need to know I need to know the moment of inertia of the hand plus whatever shape I'm holding, in order to know how much strength I need, how much torque I need to keep the hand in place. And again, that's kind of what we're doing here, is we're just applying way too much torque and then letting the dampening undo that, which means that if I now pick up something heavy, I'm dampening the movement there. Although again, my angular velocity here becoming bigger because I'm holding something heavy should allow me to correct for that. Although at that point in time, I think the problem that I have is that moment of inertia no longer is what it should be. Because I'm using this 0.2 magic number at this point in time, which doesn't make any sense. Oops. You need to do that. Okay. Also, still not entirely sure why I am, oh, sorry, a frame behind on this. That also still doesn't make any sense. Okay, let's just put that in there and also go and exclude that from still show. Okay, seeing that it's fairly precise when I'm moving my hand even fast, but it has that much when I'm moving. I think that I've got an order problem with that. um, that would suggest that my movement script might run after my hand script. It doesn't make much sense unless the priority is the opposite way around from what I think it is. Where's my ready function? Oh, I'm looking at the wrong thing. This one. Ready, 92, collision, ready, 90. Okay, so make that 94. Let's see if that makes a difference. Nope. Okay, that's very strange. Back to 90. The other option there is hold on. How am I doing it here? Not in here. So and check those. Targets, just a transfer. Okay. Next. Turns global transfer times 30. So that does this. Okay, so this could be a problem with the logic here. No, because the parent folder. What if I do print transform over here? And the layer for origin 3D. Okay. And then here. Okay. Does. Come on. Yeah. Okay. Well, we've confirmed that our player logic runs first. And then our can I turn wrapping off on this thing? No. And then it runs our our movement code. That's a good thing. Now these seem to all line up, so let's go a little bit further. No, it all looks like it lines up. Here we got a situation where I'm not actually running. Oh, my eyes are stinging. Okay. Just based on this, I dare say that we're not having a problem with getting our data in the wrong order. I've still got my print moment of inertia. And I actually have the right data that we're getting from the physics. So with that, I'm assuming that our target is okay. Oh, I'm gonna move that here, that, and now come on, work, rotate. Torque is moment of inertia times angular acceleration. So we get our moment of inertia first. Then we try and figure out what is our needed velocity. And for some reason, we need only 20% of that. Which makes absolutely no sense. So one option is that our earlers we get in the wrong order. Although I find that's very strange. The other option is that our moment of inertia All right.
Why is that just about everywhere? Well, it doesn't tell us a whole lot. Let's look at that first. Oh, that's interesting. I wonder if it ever takes the. I don't think it takes the mass into account with this. Could be. It's just a bit of a gamble, but you never know. All right. It still doesn't make sense for the 0.2, but who knows? No. That was too good to be true. Still don't get why that doesn't work properly. Hmm. Or was it? That's the other option. Actually, that's fine too.
Okay, not at all. Not at all. Not even close. Is that because hand mass and mass are different? I don't think so. It should be the same. Yeah, I set that to the same. So that was 1 divided by inertia to get inertia. And that's just to add the mass in. The mass is 0.4, so that comes close to the 0.2 that I had here. Hmm. Okay, we screwed something more up. Because now we should be back to what we were before. Unless there's something weird going on here. Because we had that before. That's where we were. Or was there something else that we changed? Well, mass and hand mass, but... I thought I removed... Oh, no, I didn't. Okay. Still being weird. So, what did we screw up? What did we change? Oh. Ooh. Ah. That is weird. That is weird. Hmm. Why are they not the same? Because I never initialize it. I can only set it. So that's in our setter, that's fine. Maybe it doesn't like that the first time around. Okay, that is really funky. Because that as was 0.4. Well, the mass was actually 1 kilo. Was working correctly. I think there's a half missing somewhere. So we have that in the factor here.
Right now, I'm just gambling. So why is that half? That would suggest that there's a mistake in here. Because multiplying this by half again would kind of undo that half. Did I get that function wrong? Or that calculation? That is just weird. I still don't get why we're lagging behind when moving. Because that still suggests that we're working like with the previous position. That doesn't make sense though. Well, I think we pretty well proved that we're doing things in the right order. Times 0.5, does it have to be? That works. Oh, yeah. And why this magic number of times 0.2? And we somehow need to adjust that by mass. And I really wonder if that's a problem because we're using Euler angles. And whether we got the Euler angles in the wrong order. Well, that's something that we might be able to further figure out here. It's Euler. Still not looking at the right position. Because that's what I'm wondering if they're, because for small angles that's all right, but the bigger the angles get, if we get the order wrong, and that way, and also for that, in that sense, is our torque actually getting that in rotations from XYZ as well? We could try. Let's put that in 0 and see if that makes a difference. Whether the rotations are always XYZ, you never know. Still have the problem that it's just not strong enough to rotate it when we're holding something. Okay. Kind of seems to work. Actually, first, before I forget. Oh. That's oh. All right, I will have to. Differentiate it with alpha. Okay. Okay. Where are we here? Oh. Oh. Oh yeah, because we're really vibrating. So okay, so what if I do 0.5 now? Does that work better? So that kind of makes sense with the other thing, but not still vibrating too much. But when I pick something up, it's fairly solid. Why, oh why is it doing that? You know, with this one, I still think it might have something to do with weight, because I think I'm not taking mass into account here. But that would then suggest that this should be 0.4. But as far as I remember, 0.4. But hold on, wait. Yes. That makes sense. Because we found out that for some reason we need to do that, the 0.5. So it stands to reason why we need to do that here. I'm going to say 0.5, but I'm going to go and multiply that by mass. Oh, that probably gives an error. I think that probably gives an error. Oh. So we can see now that our rotation is pretty damn spot on. So with our torque, we definitely need to keep the mass into account. With that, this is, oh, except for, of course, that we're getting it really weirdly bouncing. The fact that I'm now picking up 10 kilos and that it's automatically adjusting, that must have something to do with this, the linear velocity sort of getting that proper. So, we're going to call that total mass. Mass means that I'm going to go under that here, that here, and actually, if I'm smart, I'm just going to do this, this. Okay. Cool. So. I'm pretty sure that I had a pickup thing here. Yep. So here we have, if you've got something, so now we know what we picked up. Cool. And let's start by saying total mass pluses what picked up. And actually, is rigid body 3D. And we're going to say what we picked up, how much mass does that have? Okay. Whoa, that's that's definitely going really haywire now. Yeah, I get that.
And that flies off as well, which is really to be understandable because we're not taking into account proper momentum. Right. I'm really starting to feel that what we're doing here is only going to work for linear movement and not for this. So I'm just going to put that back. And then in a ready function, we put that back to very high. Now let's see. Okay, is that... So that might not have anything to do with our rotation, but it was actually our linear acceleration. That makes fairly little sense. Total mass, that's that. So here we just attach torque. Pretty sure our torque values are still what they were before. Yeah, 15, 15. It's fine. So that's all back to what it was. Okay, it's kind of doing what it did before again. Yeah. Okay, so if I just do mass here, and I only do my adjustment for rotation, well then. I should have gone back to where it was. I missed something. Yeah. What did I miss? Just doing my normal mass here. Oh, because I've still got the, yeah, of course. Left my angular dipole. Make that a bit better.
I really find that. Well, I don't find it too strange because my torque is in the kind of in the wrong place, so to speak. But yeah, it's annoying that that goes that loose. Hmm. Yeah, I think that the way that we're doing angular rotation isn't really up to par, but our linear is working. I'm kind of happy with how the linear worked. So let me move that here. So we only seem to be needing that for our linear. But yeah, I think that has a lot to do with the fact that our moment of inertia is calculated based on our hand. And obviously, once you pick up like a box, in order to know the correct amount of torque to give, we also need to know the moment of inertia for the box. I wonder. Okay, let's go crazy. This is going to be totally wrong. I'm sure. So what we're going to do now is if we have something picked up, what we have picked up is that. What we're going to do now is... Oh. We're going to reuse that probably. No, it's not get rid of this, but it's whoops. Up. Okay. I'm going to add that. This is getting really messy. Oops. All right. Let's see if that does something. No, the breakpoint. Okay. There's an error in here. Oh, it's not _4. Hour and time. Oh, it's 7:09. We can make some late dinner soon. But I just want to get this bit to work. Okay. It's better. Not much. What about you? Definitely doesn't like it too much. The thing is, we need some sort of constraint on the hand, I think. So the hand can't actually turn more. But it's still weird because in theory, something like this, even though we're not really applying the torque in the right place, but with our calculation, the fact that we're taking our mass and everything into account, we should be calculating the right torque to move. Okay. What is this? Hey? You want attention, huh? Hello. Okay. So I'm going to leave the torque calculation where we have it right now. I'm actually really happy about our linear logic. So we already removed our linear settings. So let's go a little bit further with that to make sure that our so we got a force coefficient. We're no longer going to have that. So we're going to change that to a max linear force. We obviously have no idea what that's going to be. We're going to figure out how much force we can exert. Now for that, I need a helper. Let's go and create a label. I'm going to make that visible. Child. That's going to have to be placed somewhere. Mm. You get this. Yeah, no. No. Where are you? So just reopening it just so that the label gets visible and I can see what I'm doing wrong with this label. Yay. Very good. So okay. I am going to just add a label in just for help. So I know what they're called. So pixel size. A lot smaller. Let's see. No. You want some of this? Want this? Yeah, you want that, don't you? Yeah. Look. Come in. Yep. Whoa, almost on my keyboard. Cats. There we go. Cat's got some snacks. Lucky cat. One of those. Yeah, double-sided is default all. That's cool. So we're gonna put some text there, but I need to also position it. So actually, so that I can see this. Oh, that can stay big actually. So yeah, I can see that we got them both writing on top of each other, but that's fine. Put that like this. No, I want to make sure that the text needs to be left aligned like that, and then move it like that. So that's going to be labeled horizontal alignment is left. Yep. And now transform. Oh. Yeah, excuse me. There we go. Origin of next step. That should allow us to put some info here. Now we can go to physics. I have too many methods in this thing. It's so hard to find what we're looking for. All right. So force is here. Once. Actually, let's go on strength. Now I want to just do 0 to 2 F. Send strength. So now it should be displaying that. Okay. It's going to pick that guy up. All right, so we can see that it's actually adding quite a bit of, yeah, it's definitely adjusting by that. So let's say that we give it a maximum strength of 150. Let's start there, see if that makes sense. Misty, come on. No. Yeah, you want attention. I know. I'm busy and you want attention. But you don't like this sort of attention, do you? Here. Say hello to everybody. Say hello. Say hello. No? He doesn't like that. All right, so then what we're going to do is linear force times is max force divided by strength. I'm going to adjust it. Now we need to have a sensible max strength. So we're basically going to say how much can we pull up? Where are you? Where's my fancy do it for the trees? You really can't? You're really trying to get my attention, huh? Let's go to that. So that one lower. I'm guessing that's newtons. Sure. Guessing. Or might it be Newton meters? Sure. It gets bouncy. That's the thing that I don't like about this sort of simulation, because in real life, obviously your hand, now it's connected to your brain. The moment that your hand feels something is heavy, it's going to continuously adjust how much you're pulling. Oh, that hasn't actually reset. Okay. What, this guy? That's not. Okay, so we actually weren't even applying our maximum. That was just. So it really gets bouncy. I don't like the bounciness of this. Ding, 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 ding. Okay. Why is this getting so much more all of a sudden when I'm holding it that close? That doesn't make much sense. It's like the rotational thing that's giving it a reason to move a lot. So how about when I grab my gun? Yeah, we're still seeing that that's just not giving the rotational strength that we need. So we're nowhere near how much rotational power we need to give. Yeah, we're definitely missing a lot still. Anyway, I'm getting tired and I'm getting hungry. We're getting closer and closer to where we need to be. We definitely made a lot of progress on the linear movement. There is a part of me that wonders whether I should stick with the dampening. I want to just try that just on the linear. Maybe do that last, and then I think I'm going to call it a day. I think we are getting quite close to where we want to be. Now I need to do a little bit of a gamble here. Linear velocity minus here damp delta. I'm assuming that that's a damp calculation. I'm not sure, but that's what I'm assuming. It doesn't damp as much as I had hoped. It damps a bit. But yeah, I am definitely not happy about the rotation. All right. I guess I can keep the adjusted velocity here. And actually kind of do that here as well. Now it's going to be should I write that out full? Maybe a little overkill, but that's kind of, taking a safety, really. That if I ever change the code somewhere where I accidentally suddenly I'm going to use my linear velocity for my angular velocity because I don't realize that I'm reusing a variable. Oh, this needs to also be angular damp. So now, in theory, I could track that here as well. Let's say if I do add the whole damp there. Yeah, it's pretty much still working. Yeah, it's becoming very bouncy. But I still have, well, I guess it's a little bit better, but not much. Still feel like I'm just, that really flew off. It's just, yeah. That's just not how a hand reacts. That's the problem. So we're definitely not calculating the actual angular acceleration that we need in order to get the hand in the right spot. Whee! Because, yeah, that's not how hands work. So I think we're getting close to where we need to be. I think that there is a bunch more work to do to perfect this. I am very surprised and to some extent happy about the whole velocity logic, the fact that it actually it actually, the fact that when I move my hand and I'm trying to catch up because I'm holding something heavy, it's not catching up quite as well. It's getting some more momentum. That, yeah, it's actually applying that. It's kind of neat. We'll just do that because we know we have that right now. But yeah, the angular one, I am not happy about at all. Again, picking up heavy things and it becoming bouncy, that's something that we can deal with. That's a matter of figuring out a better way to dampen things and to sort of rein in the excesses. But yeah, the rotation is a problem. I really need to figure that out. I need to figure out how can I make the rotation. I think again, I think we're in the right direction of what we're doing. But I think that these I might need to split the applied torque. Well, the other thing that I'm pretty convinced of is it all depends on the momentum. I think we don't have that right. So we're always doing just an applied torque, which is a central application. So yeah. Tricky. Don't worry about that anymore. I actually want that like this. That reads a bit better. Maybe this one is gone. Yeah, this is still weird too. Why 0.5? That to me sounds like we're not calculating the right thing somewhere. That. Hold up. Solutions distance. Yeah. Hmm. Yeah. Okay, sorry guys. I was just thinking and trying to figure this out. But yeah, I think there is somewhere something that we're missing in the way that we apply this, where it is not accurately getting us the torque that we need in order to rotate our hand into its new position. And again, it's doing it pretty well if I'm not holding anything. So I think the basis of our calculation is correct. It's just pretty sure that this part of it is not correct. This is probably just too simplistic to think that I can just add the momentums together. Plus that, I'm pretty sure that the orientation is going to be wrong. But with cubes, that doesn't really matter because they're cubes. They have equal dimensions on every on every side. But I'm guessing that if I do different sort of shapes, I need to make sure that they're either rotated into the local space of the Oh, I am already going local here. Look at that. Ooh. Oh no, here I'm doing the difference between that and that. But that's still in global. That's the thing that I don't get. This is still all in global space. And a moment of inertia is in local. And that's really what I'm wondering about is oh, I'm doing this times delta. Oh yeah, of course. Because that's it. Yeah, yeah, correct. Yeah, I'm really worried that I'm doing something as far as the torque is concerned. I'm doing something in the wrong space. Whether, as far as I know, it should be global, but definitely our moment of inertia is is not global. But that is, that would be something like that we need to do something like that. And then here, for MOE, this is going to be MOE times let's just see if that makes any improvement. Probably doesn't, but you never know. Oh, of course, I closed that. That was smart of me, wasn't it? So I need to go and undo that. I need to wait until. Yeah, I know it's such a mismatch because you always do that. I said connects. There you go. Okay, now gameplay. Okay. Yeah. No, see, because that then completely messes it up. So this is what I don't get. It makes no sense whatsoever. Is that way that gets into something semi-local? You know that works. My keyboard is in the way. Yep. No, that's totally not what it should be. I don't know. It just doesn't make any sense to me. Oh, well, one more thing I want to try is did I just put this in the wrong order? Okay. Let's hold that up in that direction. And just in case, maybe that's what I did wrong. Although it would still make sense if it's somehow, nope, that's definitely not working. Oh yeah, because now I had to put this in global and the other in. Okay. Still rotating, rotating, rotating. No. That. Yeah, last thing that I want to try. Turn the order around. Still floppy hands. But it makes a little bit more sense. But yeah. I don't know. So I think that 150 is way too little. But whichever way around it is. Also don't get the feeling that the damping is doing anything. Anyway. Last thing to try to see what it looks like. And then I'm really gonna give it up, guys. It goes seem to be a little bit better. And it's a shame because I had planned to do something completely different. Because the next thing that I want to work on, and I can't really demonstrate that right now here. I can demonstrate on that on the door. Is right now, my hand just sort of flops against the door. And you can see that's pretty. I guess I just don't have the strength to open the door right now. I'm supposed to be able to push that open, or did I only open it from the other side? That's also possible. I can't remember. Yeah, it's too close. Anyway, might just be that I made my maximum. Ooh, that I made my maximum strength too little. Just look at that. That's supposed to be over 2,000. So maybe I can no longer open the door. But again, the thing that I just wanted to show is that my hand right now just sort of plops onto that. So one of my next things that I want to start working on is I actually want to use the rigid body logic that we had with this guy over here and sort of use a version of that to make our hand or our fingers actually interact with what we touch. The other thing that's actually kind of fun to try before we call it a day is I'm going to put my controllers down. I'll figure out that I put my controllers on. There we go. So I've got my fingers properly working now. So that should still work, kind of. Although here you can see that definitely our rotational value is way off. But yeah. Yeah, so I really want to do something more that it actually interacts better with the finger collisions. And sort of put some pressure on the fingers. So that's something for another stream, I think. This is the bit that I really need to figure out. Is this rotational thing is not good. I think the actual movement is acceptable. That's definitely something that I think that with a little bit more dampening I can make work. But yeah, this should not be possible. And that is just because we do not have the right calculation to slow down the rotation. Now, one other thing that is possible is that we only use forces for linear acceleration. And that we just, well, you know, that's a last thing maybe to try. I'm actually going to put that back to 0 then, because obviously my dampening is going to be a problem. Because this was the other thing that I was testing around with, and it is, it's possible, but at the same time, it's one of those things where it has issues. But just for fun, and that actually needs to be divided by delta. All right. So we're just going to set the acceleration that we need and just let this thing figure it out itself. So, yeah. Oh, I can see that actually. And this is the problem again, is that I think the problem is that the velocity of the angular velocity of the thing that we're holding, that might be the only other way that we can do it. Is that when we this is definitely not working. But the other thing that we could try, because I think the problem that we might be having here, and that makes sense with the fact that our hands are moving correctly, is we're applying torque based on where we want the hand to be. But we have no information well, do we? The thing is, the thing that we're holding has a angular velocity as well. And we're trying to sort of work against the angular velocity of the thing that we're holding to try and put the hand back in the position that it should be. But that is not properly placed in this. So, okay. I know that I said I was gonna end the stream by now, but there's one more thing that I want to try. And for that, we are actually gonna go and I'm gonna take this out and I'm gonna move that here. So now we're gonna say, what did we pick up? Blah 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 blah. Okay. Now there's two options here. Is either we need to apply the torque to our hand, which I'm going to try first. Don't worry, I'll fix this all up in a minute. I should have just selected the whole line and under tapped, but okay. So I'm still gonna put that into global, into local for our hand. But if that really all doesn't work, then we're going to actually do more towards our thing. So now we're going to say we're actually going to do our angular velocity of what we've picked up. Okay. I think I'm going to reuse that because we want the same amount of rotation. But now our needed velocity is going to be that, because that's our needed velocity for our cube that we picked up. Then we can calculate our torque that we need for this. And then we're going to apply that torque as well. Let's see what that does. Because now we get the correct adjustment of torque for the thing that we're holding. No. So the other thing that might be is that we actually apply the torque onto the cube. That is really kind of stretching it. Still going to do the same rotation because we want the same rotation on the cube as we have that. So now we can go and just do this. Okay. That's great. That's great. But now we're going to apply this torque to what we picked up. And hopefully it's happy to actually apply that. Okay. That is that is struggling a lot. And I think the reason why that is struggling a lot is because we're not applying the torque. We're applying the torque to the center of the we're applying the torque to the center of the rigid body and not to a location in. Yeah, that isn't it. Indeed, it is. Well, the problem is you could see that there's like a ghost outline on the cube, so it is moving back and forth real quick. So it's fighting. And the problem is because we're applying the torque now on the cube, which means that it's applied on the center of the cube, which is what gives it that weird wobble. And the only way that we can fix that is if we're able to to translate the required force as a pivot. I just don't know enough about physics for this. That's really what it boils down to. I'm not a physics whiz. There's a lot of trial and error to get to somewhere that makes sense. Because we really want the torque on the hand, but I've got the feeling that we might actually be applying the right torque on the hand. But yeah, exactly. There's that sort of bouncing back and forth um, between the two rotations at different points. All right. Oops. I'm going to disable this for now. I'm going to look at that again. All right, guys. I am very sorry. My brain is struggling. Again, I said it a couple of times now. I think this is amazing progress in many ways, especially for the linear movement. Really feels to me that we've got that working fairly well. I think our biggest problem right now is, we've picked something up. And because we're doing that with joins, it is, yeah. The whole force transition between what we've picked up and everything is just not working the way that it should. Or maybe it is working how it should, but we're not able to counter that and give the correct values. Because also the thing, of course, is that even the linear motion, because I'm holding the box at an off angle, when I move my hand forward and backwards and I'm exerting that force, that is also creating a rotation, right? So there's this dynamic between the rotation that I want to reorientate the hand, the rotation being introduced by moving the hand because I'm holding something and it's not even. So yeah, it's really one of those things where it's going to be hard to figure out, okay, what exactly is the correct force? And one of the things that I really don't know about is whether I can adjust this torque accordingly. Okay, I want to try one last thing, which is going to look really crazy and it's going to fail initially. This is going to completely screw up the positioning of the hand when I'm not holding something. Yeah, it's definitely not happy about that. But now let's see if I pick up this. No, it's not enough. Even though there's this big rotation difference, it just doesn't know how much force to apply to that. And I really think that the only way to solve this and that we probably can solve is to have a closer look at what our body direct state returns for the thing that we picked up. And actually, a lot of this stuff we can actually get from the state. We don't actually have to keep going there, which is kind of cool. Oh yeah, our inverse mass wasn't being set. Because I'm really wondering, is there some information in here that will help us provide the proper values? Okay, yeah, that's really where I'm going to leave it, guys. I hope you enjoyed it. I hope it was interesting. We did struggle a lot. We learned a few things. We are not yet where we want to be, but that doesn't matter. We learned a lot of things, and we're getting closer and closer to making something that that makes sense. So I'm going to leave you all there, and yeah, thanks for watching, and hope to see you next stream. All right, have a great one.